Say again?
How do you count the percentage?
The box is always going to do 50% always. Because it's always Q3 to Q1, right? So it's 75% minus 25%. There's 50% in the box always. No, that was just decided related to the IQR thing. So guys, the 5-number summary is always the same idea, but it's almost never the same numbers because it depends on your data. So it's always lowest, Q1, Q2, Q3 highest, always. But depending on your data, how many data points there are, how big the data is, maybe it's 20, 23, 30, maybe it's 13 billion and 7. You know, so it depends on what your data is. But it's always the same idea, right? So let's go back up here. I can ask you specific percentiles. Wow, I think it's bright. So P17, what are the 2 steps? The first step is? Yeah, 17% of 20, because there's 20 data points. And it's 20. So 0.17 times 20. And by the way, percentage to decimal, right? You got to know how to do that. I always teach when I do decimal percent, if you write them in alphabetical order. If I'm changing from a percent to a decimal, I move the decimal that way. And of course it's always twice, because percent means per 100. Right? Like it, just in case anyone has trouble with that. 0.17 times 20 is? 3.4, and you round that to 4. So the 4th number is the answer. So the second step is to go find the 4th number. 70. I am. 4 level 0. There you go. So B, now this is kind of funny. When I first made this sheet, I just made these numbers up, and then I just made the questions up. So if you got the same number as the percentile, don't worry. I think that's the way it comes out. It's just coincidence. So if I take 87% of 20, so that's 0.87 times 20, what do you get? 17.4. That means 18th number is the answer. So what do you get when you go to find the 18th number? 80 freaking 7. Okay, that's. I didn't do it on purpose. You guys are like, I don't know, whatever. It's just freaky. It came out that way. Part C, I'm not asking you to calculate a percentile at all. I'm just saying, what does this mean? This idea of 35th percentile, that means what? Say again?
I said that your grade is higher than 35%.
All right, I like it. 35% of everybody else scored lower than you, or you scored higher than 35% of the other people, right? Perfect. So is that a good place to be in? No. Does that mean you made a low grade? No, it doesn't. You could have made a 90. It just happened that 65% of people made higher than a 90, right? And there have been quizzes like that given out. Certain people. All right, so here it means 35% scored below you. So it's not a good place to be. Some of the homework is going to say, how do you feel about that? She's in the 85th percentile of salary. How should she feel about that? You know, you got to actually answer that question to get credit for that homework question. What do you guys get for the 5-number summary?
69.
So the lowest one is 65.
I'm 65, sorry.
Q1. So when you do this, you get 5, which means average the 5th and 6th. And you get 71. They're both 71, which is nice. That's the best 2 numbers have to average, is when they're the same. Q2, it's half of 20 is 10, so you take the 10th and 11th. Is that cool? And you average those. What is the 10th number? 76? And the 11th number? 78? That's not too bad. That's 77. Yeah. You don't always have to do this, but you do have to show me some idea of where the number's coming from. Right? So it's always a good idea to just go ahead and put this work down, show me where that number's coming from. Q3, you could do the thing I told you earlier, or you could do 75% of 20 is 15, so you take the 15th and 16th, and you get what? 83? They're both 83? Ooh, cool. And the highest one was 99. Good for him. Okay. Not too bad, right? It's always those things, but it's just based on your data. But it's always those 5 places. The lowest, quarter of the way in, half the way in, 3/4 of the way in, the highest. And then to make a box plot, let me see. It kind of makes sense. The lowest one's 65, so it's good to start there. And I need to get up to 100, basically. So you can go by 5s, right? 65, 70, 75, 80, 85, 90, 95, 100. Come to 70. And then you just plot those down. Let's see, the lowest 65. The first quartile is 71. Bam. Second quartile 77, about right there. And the third quartile is 83, about right there. And then the highest one is 99, way out there. So you box off the middle 3 like that, bam, and then whiskers out to the side, bam. It's like, not too bad, right? So far, so good? Trust me, you're going to wish you were back here. It's a more complicated stuff. Right, so this, please don't let this be difficult. It's not supposed to be. This is called measure of relative standing. It's kind of a measure of where you are. So one reason that they do percentiles for the SAT is they change the SAT. Every time it's kind of like given out. So they could have just arbitrarily made it a little harder or a little bit easier, just randomly. So they want to base your grade kind of based on how everybody else did. If they made it harder, then everybody should do a little worse. You would stay at the same relative place. You would be in the 90th percentile because everybody would go down or go up if it's easier. Does that make sense? So that's a more fair way to represent how you stand in something. It's a percentile. Trust me, I made like a 40 on my first test in grad school, and I thought, well, shit, this must mean I shouldn't be here. And when the teacher gave it to me, he said, "Good job, Jeff." Huh? What the hell? It's like the highest grade on the test was like a 45%. And it's just the way it is in grad school. Is they just want to knock you on the test until you figure out who's really, really good. I was like, okay, great, good to know. Okay. So let's work our way up to the other side of this thing. Any questions on that side, the percentile side? B? This guy. But we got a 17.4 though. Right? What's 87% of 20? 17. Now, we do round it up to 18, but did we get a whole number when we did the calculation? No. So when we get anything that's not a whole number, what do? Round it up, take that number. So we didn't get a whole number, so there's not going to be any averaging involved. I round it up, take that number. It's only when you actually get a whole number, like we did down here. We got a 5 on the calculation. That means we have to average with the next one up. I like it.
Can you round it up 17?
Where are we at, sorry?
On the question, that one. Can you do 17?
Nope. What did I say earlier? Anything that's not a whole number, you round up.
Okay.
I like it. Just the rule, just to make it always come out the same. And really, the difference is not that big for a very large group of data. And there's no reason to be that specific when you have a very small set of data. So you can take a look at the formula the book uses. It takes into account how many repeats there are and so forth, and it really doesn't matter. But if you want to do it, you can. Okay. So this is kind of a measure of relative standing. Relative to everybody, where are you? That's what this stuff is. We're going to get into the two main things of statistics. It's going to rule our life for a while. Once we get out of probability, it's going to rule our life. These two main things are a measure of center, where's the center of the data, and a measure of spread, how spread out the data is, right? And we're going to get our first little taste of a real statistics formula. Okay, so we're going to have some Greek letters coming at us here in a minute. Oh, shit. So it's, let's see. Does this look all right? There you go. Okay. So the first thing I want to talk about is the simplest thing. You guys, we've already been doing this thing. How do you calculate the average, which in statistics we call the mean? So if I had a set of 100 data points, how would I get its average, its mean?
Add them up.
Add them up?
And divide.
Divided by?
To a number of numbers, no?
How many numbers there are? 100 in this case, right? So why was I always divided by 2 here? Because we were only adding 2 numbers. So of course I'm going to divide by 2 to get the average. Yeah. So, mean, what we call the average in the everyday world. The reason we give it a name, the mean, in the statistics is because there actually is more than one average. What we think of as the average in everyday life is really the mean. There are other ways to average. And the mean, the symbol it gets depends on if it's a population or a sample. It kind of makes sense. It's a quick way to communicate what it is you're working with. So if it's a population, the mean gets a Greek symbol, right? To make it seem more official. It's a little Greek symbol. It's the Greek symbol. Looks like a U with an extra leg. It's not an M. And it's the symbol mu. It's a Greek letter. I love it. Even before I wrote that, some of you guys had a look on your face like, what the shit? Before I wrote it. What's up, guys? No? Yes? I understand if you make a little M. I can understand that, but try not to. Let me do that again. Mew. Right, there's a little mew. Little French cow. Mew. Right, that was just for me. Close to my jerk. And the formula for it. Now remember, math people, we don't like to write a lot because some of us can't do it really well. Plus, we just like to be efficient with our time, and we're lazy. So I don't want to write. In English, it would be add all the numbers and then divide by how many there are. Right? Oh my God, that took way too long to write. So we want to write symbols that represent these ideas. Especially if the symbols, the idea keeps coming up. And there's going to be a lot of formulas in this class with this next symbol in it. So there's one symbol that we use to represent sum up the blank. And that symbol is sigma, capital sigma. Later we're going to see lowercase sigma used for something else. So that is the Greek letter S. Makes sense to use it for the sum of something. And when I write this, part of me feels a little bit like anxious because it doesn't make any damn sense unless there's something after it. This is like me saying, okay, class, sum up. And you're like, sum up what? What? So this is summation. So sum up all the numbers. So what represents all the possible values of something, you know, from algebra? What represents all the possible values of something from algebra? X. Thank you. Sum up all the numbers. So X is the symbol that we use to represent all the data points we're studying. You guys with me? Same thing in algebra. It's all the possible values, right? And then the number of numbers, how many numbers there are, the number of things. Thank God we use the letter N. Now the book makes this a capital N for population. That's kind of dumb. It's just N. It's the number of things you're looking at. How are we doing so far? So that is, in mathish, what your English understanding of mean looks like. So yes, math is a different language, and you definitely see it in statistics. You use Greek. So what symbol? This is a population mean. So a sample mean is just X with a bar on it. So I could have like two lists of data. One could be the number of beers I had last night, and the other one could be the grade I made on the quiz this morning. So I could have two data sets. And this one is X's and this one is Y's. So the average of the Y's would be Y bar. It's amazing. And then a third one that was Z, what would its average be? Z bar. No way. That's where I went last night.
Z bar. So, Professor,
Yes.
I got a dumb question. What is the difference between X and N?
X and
X and N.
X is the actual values of the data.
All right.
So if I went around and I asked people, how many TVs do you have in your house? And some people said 0, some people said 1, some people said 2. Right? Or let's say, yeah, I asked 3 people. How many do you have? And this guy says he's got 0. He's got no TVs. This guy says I got 1 TV. And this guy says he's got 2 TVs. So those are the X's. What would N be? 3. I talked to 3 people. Right?
Okay.
So N is how many people or things you actually looked at. And X is kind of like the answer from looking at those things. It's the data values you're going to work with. I like it. How you guys doing? I mean, this isn't really a new idea, but this is a new way to represent the idea. We know how to do an average, but this is how it looks like. And this is the exact same freaking formula. It just has that different symbol. So it seems like population sometimes is Greek, where samples are our letters to make the distinction. Okay, I like it. So you guys look so oppressed and depressed. I'm so sorry. Oh well, I'm used to it. I'm a math teacher. This symbol here. Let's work with this symbol for a minute, because that symbol, we're going to use it in a lot of different formulas, a lot of different ways. Yeah, let's say that my data is, let's say it looks like this. I ask people how many kids they have, and somebody says 1, 2, 3, 5. Okay, that's plenty enough kids. So amongst these people, what was the average number of kids? Well, what's N?
N is the number of people in house.
So how many people did I talk to?
Yeah.
5. Okay. So take a second to figure out what the average is. So how do you do that? You do, what's the sum of X? 13. So that goes up here. And N was 5. To divide by 5, you double this and then move the decimal back once, because you divide it by 10 now. So 2.6. Or you do this. In the calculator. 2.6. Now why is that okay to say they had 2.6 kids on average? Can you have 0.6 of a kid?
No.
No, I don't want to see that. That's some weird shit. Go over your house, put that 0.6 kid away somewhere. I don't know. But you're a kid or you're not, right? So you can't have 0.6 of a freaking kid. But the average has to be 2.6. Has to be. Because how many total kids were there? 13 kids. If I round up to 3, now it seems like there's more kids. 3 times 5 is 15. Now, if I say 3, then there must have been 15 kids. But there weren't. I'm lying then. So averages do come out to decimals, and that's fine. Doesn't mean you have some weird kid sort of phasing in and out. He's here, and then he's somewhere else. I don't know. Okay, baby. You guys cool with that so far? What do you think? So sum of X is 13. What do you think this symbol means?
Square root.
No. I say second.
What do I have to do first? What does it say? Sum up the X squares, right?
Double the number of...
It's not going to be 13 squared. What would that look like? 13 squared would look like this. That's 13 squared. So that's 169. How do I get this, though? What do I need first before I can add up the X squares? I better figure out the... I know the X. Before I can add up the X squares, I better figure out the X squares. Thank you. So what's the X squares?
1, 4, 4, 9, 25.
Now I can add them up because I got a list of them now. So why are we making a big deal out of this? Because of a lot of our formulas, you're going to say sum up, and there's going to be something after it. And what I always say is, I say, cover that symbol, and that tells you what column you need to make. I need to make a column of x squares, and then I can add them up. So if you do this in a formula, oh shit, I need a bunch of those. Let me go make a bunch of those, and then I can add them up. Don't make a big deal out of that.
Is it kind of like figuring out like the f of x thing?
Sort of, yes. You did a lot of these kind of things like f of 2x versus 2 times f of x. I mean, so there's a bit of a, and of course there's that infamous negative 2 squared versus negative 2 squared, and which one's negative, which one's positive. So it's sort of related to that too. But this is different because that symbol we haven't seen before. But it is sort of like a function. All right, everybody okay at the moment? Nothing too freaky? So what have I said? So what's that going to be? What do you get? Nobody did it? 43, yes. It's kind of disheartening there for a second. So what have I said? Okay, I want the sum of x minus 1.
No.
So then you need a column of those, right? So then you just make another column. You make column x minus 1. So what? 0.
Negative 2.
2 minus 1.
1.
What are you guys doing? It says x minus 1. So here it's 2 minus 1. Here it's 2 minus 1. Here's 3 minus 1. Here's 5 minus 1. And that, of course, is
8.
6, 7, 8. Do you guys get the idea? I'm not saying that that's going to be in a formula, but the idea of a summation symbol will be. That's what this is. It's a summation symbol. Uppercase sigma. That's not really as important as knowing this is a summation symbol. I like it. Okay. And you're all like, good Lord, I had no idea we could talk about the average so much. But
Okay, it's just a
this is
symbol, but that has no value, right?
say again?
It's a symbol, but it has no value.
Oh, yeah, by itself. It's not a value, it's a process. It's telling you something to do.
Yeah.
X holds the values. This tells me what to do with them. I like it. So if you wrote this by itself, part of me is like, oh, finish that sentence. Shit. It's like they don't play the last note, and you're like, please. All right. So me writing f of, put something in there. Okay. So the mean is not the only way to find the center. When we're talking about incomes, and especially around here, house prices, right? I want to give you an example of somebody starting a job, and he's like, how much money could I expect to make? And let's say that's a very small company. They have 3 employees and then a CEO, and he's hiring a 4th employee on. Okay, and let's say the one guy makes $40,000 a year, somebody else makes $42,000, somebody else $45,000, and the CEO makes $400,000 a year. Right? Roughly mimics the real world. So this guy is starting on entry-level position. He's like, how much money could I expect to be making here in a few years? If you tell him the average of those, is that being honest? What is the average, by the way? 4 is 31.175. Yeah. So the average is 131.7, and that's really $131,750. If I tell him you can expect to be making that much money, that is a lie. Outright. So there's a better way to figure out a center of this data. And that would be the thing we already talked about. What is the 50th percentile? What is the middle of the data? Because figuring out what the middle is doesn't give a shit what that number is. Right? Where's the middle of the data? What's the middle of the data going to be? It's going to be...
42.
No, come on.
43.
Like 40.
In the middle of those two, right?
43.5.
You with me? What's half of 4? 2. We got a whole number. We've got to take the second and the third and average them. Are you guys with me?
Yeah.
This is the thing I was talking about earlier. Where for 4, the middle of the middle is the middle. Shit, it's so middle. So what should I tell him is the median. That's what we're talking about right now, which is related to P50. It is P50. The median is the middle. It wouldn't give a shit if I made this 800,000, 800. It'd still be in the middle of 42 and 45, wouldn't it? Outliers, extreme values do not affect the median. That's why when you look in the newspaper, did you know they still exist? Or maybe online or something, wherever the hell you guys get news nowadays. Shit. They always report the median home price, the median income, for this reason, especially in this region. Oh my God! You go to La Jolla, hello, go walking like there's somebody else, somewhere I'll never live. That's good. Right. It's pretty. So the median has a symbol of its own. It's like an X with a little broken thing on its head. Poor little dude, little tilde. And the median's always just P50. It's the middle of the data. Right? In this case, the median would be 43.5 or $43,500. That is much more honest of a number to give to this person, right? Okay, I like it. So median is a better measure of center when there are extreme values, extreme highs or extreme lows. But it's just another way to measure the center. This is still just a way to find the center. I like it. How are we doing so far? Yes. Okay. This is better than percentile. All right. So we got Sorry. We got the idea of mean, median. Now, what kind of sucks about these two is neither one of these works with qualitative data. Right? What's qualitative data? Categorical. Right? Like hair colors or types of cars. Right? Can you find the average hair color? No. Right? Can you find the median type of car? No. Doesn't make any damn sense. The next thing works with both quantitative and qualitative, and it's called the mode. You can tell me in the mode, who knows what the mode is? It's the number occurs the most occurring number, or the most occurring thing in your data, to be honest. So if I had a bunch of cars in a parking lot, I could figure out the modal car. Which type of car occurs the most? Which hair color occurs the most? It works with any kind of data. Obviously, it's going to work with this kind of data. Is there a mode here? No. Nothing occurs more. They're all ones, right? So the mode, number occurs the most, or whatever it is, the thing that occurs the most. So, for example, if I had 1, 2, 4, 4, 6, the mode, of course, would be 4. Poor little mode doesn't get a symbol. Poor little thing. Yeah, exactly. Mode is 4. What if I had this data here? 1, 2, 2, 5, 6, 6. Yeah, it's bimodal. I love it. What if I had 1, 2, 2, 5, 6, 6, 6? Yeah, there's a winner.
There's one that
6. I like it. So the mode is the one that occurs the most. This book goes up to trimodal, if I remember correctly, but after that you're like, screw it. There's no mode. You're trying to figure out where does the data seem to cluster. Where's it clustering? So that's what the mode does. It's a different way to measure the center of something, where things seem to be clustering. So this would be just 6. Unimodal. Like unicycle. Bimodal. I like it. Cool. So, did I put on here? Yes, I did. Last one, and then we're going to work on the back side of this, and then it's probably going to be, oh, it's already almost about time. Like, somebody remind me, what's the range of a set of data? Yeah, the range is the high minus low. The mid-range, this is another measure of center, mid-range. The middle of the range. How do I find the middle of any two numbers? Add them together. Divide by 2. So the mid-range is the middle of the range. This is kind of evil. It's, of course, high plus low, because I'm trying to find the middle. I've got to average it, so I add them together. But the range itself, of course, is high minus low. How far apart are they? And it's a little bit evil. One's a minus, one's a plus. Oh well. So tell you what, in the waning minutes here, if you group up with like 3 other people, you can give each of your little members a different set of data. Do you see what I'm saying? It's up to you. You do it all yourself, and you got 4 times the work to do. Just try to get the first part of this done. We might end up finishing this next time.
Did we only get through section 2.3 today?
No, we just did, believe it or not, 2.3 was percentiles. 2.4 was box plots. I don't know why they put them in a different place. We are in 2.5 right now.
Okay.
Yeah.